Good afternoon. A little bit about mag particle here. Just a quick little video to kind of show us something about a pi gauge. Okay, got a pi gauge here. We flip it over, we see we've got the eight chunks of steel in there. Get it a little bit closer so we can actually see it here. Got our 8 chunks of steel. And then we've got our other side here that we're going to apply our particles to. Okay, pi gauge, as we already know, is good for field direction. Okay, so if we lay this guy here and we put our poles of our yoke here, we've got longitudinal magnetism running through the piece. Pi gauge is in the middle of it, so we should see defects that are 90 degrees or perpendicular to that. So this is the yoke we're going to use. Okay, just a regular old Parker probe here. I'm going to put my yoke just as straight as I can. Actually, let me turn that, doesn't really matter. Okay, I don't know if you can hear that, but you can tell I'm actually turning the yoke on. Okay, so I've got my yoke on, got just my regular old magnetic particles here. Okay, I'm trying to put them on as decently as I can without making a huge mess. There, we're getting somewhere. Now we can see them start to develop. Okay, as we can see, our longitudinal magnetism is running between pole to pole. Whoops, I just hit that there. And then we're going to see defects that are at least 45 degrees to 90 degrees of that magnetism. So if I were to turn this, okay, start this all over, just get these particles off of here, start this process all over, leaving my pi gauge pointed the same direction, my field lines are going to change a little bit. Okay, this one's not as prevalent now. This one's pretty good and that one's okay. Okay, be the same kind of thing if I went like this. I would start to lose this line, but I'd gain this one back. Whoops. That's what I hate about mag. And you can see that right there. Got really two very solid lines, but not necessarily my particles for my line following me here. So as you see, that something pretty simple. Just shows us a little bit of use of the pi gauge, kind of where it came from, what it's all about. I'm going to make a little bit of a mess here for now. Get rid of all this stuff on here. These particles will go in the trash in a minute. So, no particles on here. Brand new piece. Okay, never tested it before. We're going to do an X pattern because there's actually a weld through here. So I'm going to start like this for now. And you can see pretty quickly we had an indication develop right here, and there's actually one over here. Same piece we did for our penetrant video, if you watch the penetrant video. And you can tell, there they are. Okay, at least 45 to 90 degrees of my magnetic flux, which is good. That tells me, alright, I've got a leakage field here and a leakage field here, and I've caught them both in one swipe. So let me change directions here a little bit. Go the opposite, and see if that's still the case when I change directions this way. Okay, I got excess particles. That guy came right back. This one didn't. Okay, because of how those field lines are oriented, it's not as clear as it was when we were going this way. So that shows us a little bit about orientation of magnetic fields and what we're going to get for actual defects. So, not too big of a deal. Yoke applications are fairly simple after you get past all of the dead weight checks and all that stuff. But once you understand what a yoke actually does for you, it's a very, very good inspection. Okay, so a little bit about a pi gauge and a little bit about a yoke, and I hope that helped, at least give you a little bit of an idea of what it's all about.